Alright, so year 9, so this is direct proportion, lesson 3. This lesson we are going to discuss how to set up algebraic expressions, or we call algebraic rule, for certain direct proportions. Okay, so let's first look at certain patterns for direct proportion. For example, we understand that if we see something like time and distance, and you will see when the time changes, the distance will be changed by the by the same factor. That's what we call double line method. Okay, one way is doing this. Okay, alright, so when 1.5 times 2, it gives you 3, and at the same time, if you consider the distance covered, it would be the same, like from 1 to 2 is times 2. Alright, so you see the factors will be the same. Okay, so that's what we call direct proportion. Okay, and this time we're more interested to look at the relationship between the two quantities when we compare them. Okay, by using time and distance when we compare them. Okay, so let's say if I try to divide one quantity with the other, then what happens? Okay, so if I use 1.5 divided by 1, of course this one equals 1.5. If I use 3 divided by 2, of course this one equals 1.5 as well. And also if you divide 4.5 by 3, it also equals 1.5. So it's always 1.5. Okay, so that means if two quantities are in direct proportion, then the ratio or the rates between the two quantities will be a constant. Okay, so actually we have mentioned that before, that a direct proportion is meaning that a constant rate or constant ratio between two quantities. Okay, so that's what we are going to write. Okay, so from now on, we are going to use a special symbol to represent the direct proportion or direct variation. Okay, so this symbol is like this. So you follow me to write once. Okay, so this is called the symbol for direct proportion. Okay, it's like this. You can write the symbol. And when we say y varies directly with x, while y and x are in direct proportion, then we write the symbol like this. Okay, if you use that symbol, y, the symbol, and x, that means y is in direct proportion with x. And since y and x are in direct proportion, that's another way to look at, because we know y over x is a constant. Then we could say y equals k over x, k times x, right? So the reason is, let me say it again, because for any direct proportion, you will see the ratio between two quantities must be a constant. So we might write for two quantities here, one is d, the other is t, you might write t over d is a constant. Okay, and normally in math, we use k to denote for the constant. So if t over d is a constant k, then when you multiply d to the other side, you will have t equals k times d. So similarly, if y is in direct variation with x, then we could write y equals k times x, and that k is what we call proportionality, constant or proportionality. And the statement y equals kx is called proportionality statement, right? So the equation y equals kx is called proportionality statement, and the constant k is called constant or proportionality. Okay, so let's have a look at an example. So let's given y is directly proportional to x. Part A, you are asked to write the proportionality statement. Okay. So, what is a proportionality statement? It will be just like this. Y equals kx. That will be the proportionality statement. The reason is that it's given y is in direct proportion to x. Then you could write y equals kx. Okay. So part B, you are going to find the value of k. And they need to give you a pair of values for y and x. So if it's given y equals 15 and x is 3, how could we find k? Remember, we've already got an equation. That's the statement of proportionality, which is y equals kx. Since now y is 15, x is 3, and you just put numbers into the equation, and you will have 15 equals k times 3, and you could find k by dividing 3 to the other side, and that's k is 5, and y equals 5 for x. Okay, right? Let's look at another situation. So part B, they give you x to find y. Part C, part B is about to give you x and y. You are going to find k. Part C, you are going to find y when x is given. Remember now, we've got k equals 5. So the rule becomes y equals 5x. And you are now going to find y given x equal to 7. So y equals 5x, and y equals 5 times 7, and y equals 37. That's it. All good? Alright, so let's move on to example 2. For example 2 is similar to the previous example. Y is directly proportional to x, so that's a given. Write the proportionality statement. Okay? Proportionality statement means you need to write something like y equals kx. Okay? But you need to state the reason why. How could you do so? Because y is in direct proportion to x. As a result, we will have y equals kx. Okay, so that's it. Now, we move on to part B. Y is 27 when x is 3, so you are going to find k. So y is 27. So we use this rule, and y is 27, x is 3. You need to find k. Okay, so you divide 3 on both sides. K is 9. Okay, find x when y is 35. Alright. How could you do that? Again, now since you've got k, you just put k back into the equation. Right, now y equals 9x, and we have y equals 35. Okay, and need to find x. How could we find x? You divide 9 to the other side. and the value you got will be 35 divided by 9. Sorry. Possibly if you want to have a decimal number, that's okay. Okay, the decimal number will be 3.8. Okay, it's recurrent decimal. Right, so this would be one of the typical type of examples. They ask you to write the proportionality statement, then they just give you pairs of values, so you could find k. In the end, after you got the rule, you got y equal to a certain number times x, they will ask you to find one of the value given the other. Okay, move on to example 3. Given y is directly proportional to x, and y equals 12 when x equals 3, find the constant of proportionality and state the rule linking y and x. Okay, so there are two parts of the question. The first part, you need to find a constant of proportionality, that means k. The second part of it, state the rule linking y and x. Okay, so you need to find the rule, that means you need to find k and write the rule as y equals something times x. Okay, like given y directly proportional to x, that means to start with, you need to write y directly proportional to x. Okay, y equals kx. Right, y is 12 and x is 3. Can you find k? Is 4. Right, so that's the first part of the question. So you have found constant proportionality. Next one, you are going to state the rule linking y and x. Okay, the rule would be y equals k now is found as 4. Alright, so that's y equals 4x. Okay, so example 4 is very similar to example 3. So possibly for you to take some time, try to do it. Okay, and we'll come back and check the answer, right? Possibly you need at least 5 minutes to do this one. Okay, here's the rule. It's quite simple, isn't it? Alright, okay, so let's move on to our next part. Right, so the second part of this video is about use algebraic rule to solve problem of direct proportion. Alright, so let's see, this is a problem. The weight of $1 coins in a bag varies directly as the number of coins. Okay, so here there are two quantities. One is the weight of the coin. The other is the number of the coin, which is n. And they are in direct proportion because they varies directly. So that's another way to say it. You could say they are in direct proportion. Okay, you could say they are proportional. There are different ways to say it. Okay, the first question, A, is about relationship between, that's W, and N. How could we find the relationship? Okay, to find the relationship between W and N, we need to understand that the relationship is a direct proportion. So that's what I'm going to write. And from that we know W equals K times N. Alright, so when you try to define a relationship, of course, now you have an equation. But we need to find that's K. Otherwise, we don't know whether that equation can be used to find the values of W and N because K is still unknown. So you need to find K. How could we do that? Okay, you see that's one particular information which is useful. So that says 20 coins weigh 180 grams. So that means 20 means number of coins, and 180 grams, that of course means weight. Okay, so let's do the substitution. Alright, okay, so how could we find that K? We just use 180 divided by 20, and you will have 9 by doing so. Okay, so when K is 9, that means we find the proportionality constant, and you could define the relationship by using, okay, so the rule or the relationship now is W equals 9n. Alright, and B, how much will, so part B, how much will 57 coins weigh? So this time they give you n, and we are going to find W. Remember now we have that rule which will be very useful. You got 57 coins, that means n equal to 57. You need to find weight W. Okay, it would be like this, and that's 513 grams. Alright, for part C, how many coins weigh 252 grams? Again, we're going to use this relation, and this time they give you the W, which is 252 grams, and there'll be 28. Alright, okay, that's it. So here's the last example. I think the content so far for this video is quite straightforward. You just be aware of the substitution and your presentation, that will be fine. Alright, so I'm going to give you some time. Try to work on this by yourself, and then we check the answer. Alright. Okay, so here's the answer, right? Okay, so for part A, you're going to set up the equation, which you need to acknowledge that this is a direct proportion question, and then you just substituting the given condition, that's $135 for 6 hours work. And when you put those numbers in, you got K equal to 22.5. But by having that, you could move on to part B. For part B, you are going to substitute that x equal to 10, and you get y equal to the pay you get, right? And part C, you're going to find the number of hours. This time they give you the total pay, and you use the total pay divided by use the total pay 180 equals 22.5 times x, and you find the number of hours as 8 hours. Alright, so this chapter or this video is very simple. It just involves the process that we set up a rule for direct proportion. Okay, so there are some practice questions for you to try by yourself, and you can track the answer from the notes. Alright, okay, so that's for today's video. See you next time.